We'll now continue with section 1.5 and discuss absolute value equations. Linear absolute value equations with one variable are very closely related to linear equations and are solved in a similar manner. Let's try some examples. Our first example is a basic absolute value equation where we have the absolute value of 3x minus 2 and we have that equal to 1. What we want to do with this equation is we want to remember that an absolute value equation has two possibilities. So let's just take an absolute value number for a minute and let's think about what can happen. In order for an absolute value to equal, say, 5, there are two possibilities. Either the thing that's inside can either be a positive 5 and we can have that work and be a true statement, or we could have a negative 5 inside the absolute value and that would also be 5. So in order to get an answer of 5, there are two possibilities that we must consider. And so here's what's going to happen. When we take this first problem, this 3x minus 2, we're going to look at it as being two possibilities. So we're going to say either what's inside the 3x minus 2 is going to equal 1 and we're going to be fine. That's essentially this scenario where it was already positive. We didn't really need the absolute value, but the absolute value kept it the same. The other possibility is that we had a negative inside the absolute value. Now I am going to put this in parentheses. So what was inside the absolute value actually had a negative on it, like this negative 5, and that turned it to a positive 1. And so what we're going to need to do is we're going to need to consider both of those options. All right, so I'm going to go to the next screen and we're actually going to work this thing out. So we're saying that then we have 3x minus 2 is equal to 1 as one possibility, or it could have been negative. And so in that case we would have negative, and then in parentheses 3x minus 2 is equal to 1. And we're going to work this for both of these equations, and they'll work very similar to what we've been doing with our linear equations. We're going to add 2 to both sides, which is going to give me 3x is equal to 3. We'll then divide both sides by 3, which is going to give me one solution of x is equal to 1. And then we're going to do the same thing for our second option. Now we're going to take that negative that's outside the parenthesis and we're going to distribute it inside the parenthesis. So that's going to give me a negative 3x and a positive 2 is equal to 1. We're going to subtract the 2 from both sides. So we have negative 3x is equal to negative 1. And then we will divide both sides by negative 3, giving me an answer of x is equal to positive 1/3, as those negatives will cancel out. Now, these do need to be checked, and so we would want to take both of those solutions, plug them back into the original problem, and make sure that they work. Now, in the interest of time, I'm going to show you one of those and tell you that they both actually do work. But you would want to check them both. So if you want to check the positive 1, for example, you are going to take the 1 and plug it into the original problem. And so in place of this x, we're going to put a 1. And so we have the absolute value of 3 minus 2, which is the absolute value of 1, which is equal to 1. And we know that that actually is a solution. And you could do the same thing for 1/3, plugging it in, making sure that it actually works. But as I said, both of these are solutions to that absolute value equation. All right, so let's go on and let's look at part B of this problem. Now, part B is a little bit different because it has an absolute value on both sides of the expression. So let's think about this just for a second. This actually produces 4 different possibilities instead of just 2. So here's what we have. This is our original problem. X minus 4 is equal to 2x plus 1 with both sides in an absolute value. All right, so remember that the part that's inside the absolute value can either be positive or negative. And so look at the blue options over here. So this one and this one. Okay, so these are the two options where the x minus 4 is positive or negative, and the 2x plus 1 is either positive or negative. All right, now look at those two blue expressions and notice that they are actually equivalent, that they're actually the same expression. So we know that that's the case because we could take the second expression and we could divide it by -1. And if we do that, the negatives will cancel, giving us the first expression. All right, so we really only need to consider one of those possibilities. All right, look at the pink two options. Again, we're looking at the possibility where the x minus 4 is positive and negative, paired with the options where the 2x plus 1 is either positive or negative. And again, we're looking at two statements that are basically the same, because if we take the second statement and we divide by -1 on both sides, the first one becomes positive, which matches the first part of the first expression, and the second one becomes negative, and so that matches that. So we don't really have 4 different possibilities, we really have 2. Okay, so let's go and let's look at solving those 2 possibilities that we have. All right, so I've written down 2 of the options. Okay, so the x minus 4 is equal to the 2x plus 1. That is this first one. And then the negative x minus 4 is equal to 2x plus 1. That's going to be this one. And you could really use any of those that are paired up. You just want one of each. All right, so let's solve it and let's make sure that we get solutions that work. So we're going to begin on the first one by subtracting the 2x from both sides. So that's going to give me a negative x minus 4 is equal to 1. We'll then add a 4 to both sides, which gives me a negative x is equal to 5. We'll then divide both sides by -1, giving me a solution of x is equal to -5 as one possibility. We'll do the same thing on the other side. We'll begin by distributing our negative through our parentheses, so that's going to become negative x positive 4 is equal to 2x plus 1. We'll subtract the 2x. It's going to give me negative 3x plus 4 is equal to 1. We'll subtract the 4, giving me negative 3x is equal to -3. Dividing by -3 gives me x is equal to 1 as my second solution. Now again, you need to check to be sure that both of those are solutions to the original equation. And so you would want to plug in the -5 into the original problem, make sure it gives you a true statement, and also plug in the 1 into the original problem and make sure that it gives you a true statement. If both do, then both are solutions to the linear equation. Okay, so moving on to part C, our last part in this one, we have the absolute value of 6x minus 7 plus 5 is equal to 3. Now, the first thing that we want to do in this one is we want to isolate that absolute value. We want to do what we can to make this problem a little bit easier to deal with. So I'm going to go ahead right off the bat and I'm going to subtract the 5 from both sides. And then I'm going to rewrite my problem. So I have the absolute value of 6x minus 7 is equal to -2. Now remember that we have two possibilities for what's in the absolute value. So either it is positive, and we have 6x minus 7 is equal to negative 2, or we have it as a negative. 6x minus 7 is equal to negative 2. And so we'll work both of these problems out. All right, so we begin by adding 7 to both sides on the first one, which gives me 6x is equal to 5. And then we're going to divide both sides by 6. So x is equal to 5 over 6 as one possible solution. On the other side, we're going to distribute our negatives, so we'll have negative 6x. Positive 7 is equal to negative 2 when we begin solving this one by subtracting 7 from both sides, which gives me negative 6x is equal to negative 9. We divide both sides by negative 6, which gives me x is equal to negative 9 over negative 6, which is going to reduce to 3 over 2. Now again, you want to check these. And I'm going to show you on this one why it's so important to check your answers on the absolute value equations to be sure that you have correct solutions. So if I take the 5 over 6 and I plug it back into the original problem, so I would have the absolute value of 6. I would plug in 5/6 minus 7. And then outside of the absolute value, I have plus 5 is equal to 3. So here, the 6's will cancel out, leaving you just the absolute value of 5 minus 7. Plus 5 is equal to 3. 5 minus 7 is negative 2. That stays in the absolute value. Plus 5 is equal to 3. The absolute value of negative 2 is positive 2. And 2 plus 5 does not equal 3. And so, since this does not appear to check, we would want to throw out the 5 over 6 and say that that is not a solution to our problem. Let's do the same thing for the 3/2. So I'm going to come in here and I'm going to plug in a 3 over 2. And then we'll work it out from there. So 6 times 3 is 18, divided by 2 is 9. So I have the absolute value of 9 minus 7, plus 5 is equal to 3. 9 minus 7 is 2. It's positive, so we don't really need the absolute value. 2 plus 5 is equal to 3. And again, we run into a problem with that solution. We'll throw it out as well. And so the solution set to this absolute value equation is that there are no solutions that work.